As we have studied the major laws and minor laws, let us derive what is Darcy's equation for major laws over here. For that, we need to consider flow through a pipe. So let us study what is Darcy's equation. Rather, it is also called as Weisbach and Darcy's equation for fluid friction. Now, we have already seen what is Darcy's and Weisbach equation for fluid friction. So we have studied that is the fluid friction is equals to that is FLV square upon 2GD. So we have to find out, we have to prove this head loss due to friction is FLV square upon 2GD. Now for that, we need to consider a pipe having a length L. So let us consider a pipe. Let us consider this as section 1-1 and this as section 2-2. Between section 1-1 and section 2-2 there is some length L. And let us consider the pressure over here as P1 and the pressure on section 2-2 as P2, and over here P1 is greater than P2, hence the flow will be from section 1-1 to section 2-2. Now when it is flowing from section 1 to section 2-2, there will be some fluid friction on the surface of the pipe, so that friction will calculate according to Bernoulli's equation. So let us apply Bernoulli's equation over here for this entire section. So let us define a datum line also for applying Bernoulli's equation. So let us consider this as the datum line. So once we have got the datum line or the reference line, we can see that Z1 is equals to Z2, as well as we can see the diameter at D1 is equals to diameter of D2. That means there is the same velocity V1 is equals to V2, because the entire section having a uniform diameter, and once it has uniform diameter, it has a uniform cross-sectional area. According to continuity equation, we'll get the velocity at section 1-1 is equals to the velocity at section 2-2. So now, keeping this into consideration, let us write down Bernoulli's equation of motion. So, applying Bernoulli's equation, what do we get? P1 upon rho G plus V1 square by 2G plus Z1 is equals to P2 upon rho G plus V2 square by 2G plus Z2 plus some head loss due to the friction. Now over here we have already written, since V1 will be equals to V2, since area A1 is equals to A2, because diameter D1 is equals to D2, V1 will be equals to V2, and we also know that Z1 is equals to Z2 because they are at the same reference or datum line. So we can cancel these terms, V1, V2, Z1, Z2. What we will be left with, that is the head loss due to friction is difference of P1 minus P2 upon rho G. So the head loss due to friction is due to the difference in pressure for a horizontal pipe having a uniform cross-sectional area. Now, let us write down the equation for this entire pipe which has pressure P1. So let us draw the pipe all over again and let us give this as equation number 1. So we have a pipe Now over here we have pressure P1, here we have pressure P2. So now over here we have to calculate what is summation of Fx. Now let us understand this part, that in this there will be a pressure P1, this will be the driving force, and the opposing force will be the force due to P2, as well as the frictional force offered between this entire end of the pipe, that will be the friction force applied on the inner part of that entire cylinder. So let us write this down, that is, first let us write down, that is P1 into area of cross section, that is the force applied in this direction, minus of P2 into area of cross section, that is the force applied towards left, will be equals to the friction force, frictional force. Now let us evaluate this frictional force. Now the formula for this frictional force is given by Freud. Now Freud is a scientist which calculated this frictional force, and this frictional force is given as is equals to, that is, frictional resistance per unit area per unit velocity into area of cross section into velocity square. Rather, this is not area of cross section, this is surface area. Now this coefficient is given as F dash. The area of cross section is surface area into the velocity square. Now this equation was given by scientist called as Freud. Now this equation is Freud equation of friction. Now let us substitute this value in this equation. So what do we get over here as P1 minus P2 into area of cross section, because the entire pressure will be acted at area of cross section, will be equals to, that is F dash, that is the fluid resistance or frictional resistance offered per unit area per unit velocity into area of surface into velocity square. Now this is given by a scientist called as Freud, that is Freud equation of friction. Now let us substitute what are values of cross-sectional area and surface area. So for a cylinder, in this entire part, let us consider, for a cylinder the surface area will be equals to, area of surface will be equals to pi d into L if the length of this entire part is L and the diameter, which is d, constant at both the parts, and cross-sectional area is equals to pi by 4 d square, which is the cross-sectional area over here for diameter d, where the pressure is actually acting. So now we know what is cross-sectional area as well as we know what is surface area. Let us substitute in this equation. So what do we get this as? Therefore P1 minus P2, this is pi by 4 d square. I'll write them down this as capital D square. This will be F dash pi dl into V square. The value of pi and value of pi will go away, and value of d, one value of d, this will go away. So what we get after evaluating this component, that is P1 minus P2 into d by 4 is equals to F dash L V square. So P1 minus P2 P1 minus P2 will be equals to 4F dash L V square upon D. Now, we already know that the head loss due to friction, or HF is given as P1 minus P2 upon rho into G. So, this part will be equals to F 4F dash L V square upon rho G into D. So we have got value of head loss due to friction, but this friction is in terms of frictional resistance per unit area per unit volume. Now let us understand this part properly, which we'll study now, that is the frictional force per unit volume, per unit area per unit velocity, pardon me, plus then we'll study what is coefficient of friction, and then we'll study what is frictional factor. So now let us write this equation in terms of three components, that is coefficient of friction, friction factor, as well as frictional force per unit area and per unit velocity. So HF over here will be equals to 4F dash L V square upon rho G into D. Now let us see what is F dash, then we'll see what is F double dash, and then we'll see at the end what is F. Now what is F? This is frictional resistance per unit area per unit velocity. Next is F double dash. This is called as coefficient of friction. Coefficient of friction. And the third part is called as friction factor. Now, all these three parts are related to each other. That is, F dash is equals to F double dash into rho upon 2. And that is a relation between these two physical quantities, that is frictional resistance per unit area per unit velocity and coefficient of friction. Now next part is a relation between these two parts, that is a friction factor and coefficient of friction. Now how they are related? That is friction factor F is 4 times the coefficient of friction. Now we'll put this in this equation and we'll calculate in terms of first coefficient of friction. So this will be equals to the head loss due to friction is equals to, that is 4 F double dash instead of F dash over here into rho into L V square upon rho into G into D. Now the value of rho will go away, and along with that we have value of 2. So these are both related in this manner. Now, so after cutting all the elements, what we get, that is FL double dash L V square upon 2GD. Now this is what is the head loss due to friction in terms of coefficient of friction. Now the next part, what we'll do, that is the head loss due to friction in terms of frictional factor. Now we have HF is equals to 4F double dash LV square upon 2GD, and the frictional force over here will be equals to, that is equals to FLV square upon 2GD, because friction factor is 4 times the coefficient of friction, that is HF. Now we have proved that is head loss due to friction, that is the major loss, is FLV square upon 2GD, where F is friction factor, or we can also call that as Darcy's coefficient of friction. So I hope you have understood how we calculate the frictional force, or rather frictional head loss, in terms of friction factor. Now we will study this in further with respect to the flow rate in that entire pipe. Now we know that Q equals to, that is area, that is equals to area into velocity. So velocity will be equals to flow rate upon area. So this will be Q upon pi by 4 d square. And if I write about V square, so this will be equals to Q square upon pi by 4 the whole square into d raised to 4. Let us substitute the value of velocity in this equation. Now this will be the head loss in terms of velocity. The next part which will derive, that will be the head loss in terms of flow rate. So now let us substitute. So HF, that is head loss due to friction, is equals to FL Q square upon 2 into G into pi by 4 the whole square into d raised to 4 into d. So we have substituted that. So what we'll get this as HF is equals to FL Q square upon G into we'll write down, this is 2 into pi square upon 16 into d raised to 5. Now this value is constant, this comes out to be HF, so this part will be constant, so this is FL Q square upon 12.1 into d raised to 5. So now this is head loss due to friction in terms of that is in terms of flow rate, whereas the previous equation, which consisted of velocity, that is given as FLV square upon 2GD, this is head loss in terms of velocity. So either of them we can use for solving problems. Now let us understand what is F over here. This F is called as fluid friction. This F is called as friction factor. So now let us understand friction factor over here. This is termed as F. Now this friction factor F is equals to 16 upon Reynolds number if the flow is a laminar. So if the flow is laminar, first we have to calculate what is Reynolds number. You have to divide the Reynolds number by 15 for a friction factor for a laminar flow. And for turbulent flow, friction factor is equals to 0.09 Re raised to 1 by 4. This will be for a turbulent flow. So this friction factor is for laminar flow and this is for turbulent flow. Now this friction factor versus Reynolds number, if we draw a graph, so initially the graph is going to decrease with friction factor, then it remains constant, and then it gradually decreases further. So this is graph of friction factor versus Reynolds number. So I hope you have understood what is derivation of Weisbach and Darcy's equation. We have calculated what is friction loss in terms of flow rate as well as velocities in four different forms, that is in coefficient of friction, that is in friction factor, in the form of friction resistance per unit velocity per unit area, and in terms of flow rate. I hope you have understood the derivation. Thank you.